In this section, we are going to discuss radian measures for angles. In the last section, we looked at the unit circle in degrees, and now we're going to do radians. Before we get into that, a couple key vocabulary words in this section. A central angle is defined as an angle whose vertex is the center of the circle. An intercepted arc is the arc whose endpoints are on the rays of that angle. And a radian is defined as the length of an arc that's equal to the radius of a circle. And the important thing to know about radians is that pi radians is equal to 180 degrees. So a semicircle, like the top half of the unit circle, is, we called it 180 degrees last week, if the initial side is 0. That's equal to pi radians. And a full circle is equal to 2 pi radians. One of the things you need to be able to do is to convert between radians and degrees. Since pi radians is 180 degrees, if you have an angle in degrees and you want to convert to radians, you're going to multiply by pi over 180. And we can use our skills of simplifying fractions. Since 480 is really over 1, if a number on the top and the bottom can be divided by the same thing, you can reduce ahead of time before multiplying. So 480 and 180 could first both be divided by 10, or I'm just going to cancel off that 0. And 48 and 18 can both be divided by 6, giving me an 8 and a 3. And so I end up with 8 pi over 3 radians. And the next one, same thing, times pi over 180. We get, again, we're going to cancel ahead of time. I'm going to ditch the zeros and divide both of those by 2. Negative 22 divided by 2 will be negative 11, and 18 divided by 2 is 9. So we end up with negative 11 pi over 9 radians. Okay, and then converting to degrees, we're going to multiply by 180 over pi. And notice the pi cancels out. And then we're also going to simplify the same way we just did. 10 and 180 can both be divided by 10, or we'll ditch those zeros. And 3 times 18 is 54 degrees. And in the next one, times 180 over pi, the pi cancels, and 9 and 180 can both be divided by 9. 9 divided by 9 is 1. 180 divided by 9 is 20. And then negative 4 times 20, multiply across, we get negative 80 degrees. Now we're going to fill in the rest of our unit circle by labeling the angles in radians. If you recall from the last section, we divided the unit circle up by angles in degrees, and we found the coordinates of these points using special right triangles. The unit circle is a circle whose radius is 1, which is how we get the points 1, 0, 0, 1, negative 1, 0, 0, negative 1, and the other coordinates came from 30, 60, 90 triangles and 45, 45, 90 triangles. But you do want to memorize these coordinates so you don't have to solve special right triangles every time you want to evaluate a trig function. Now for our angles in radians. First we're going to start with 0 radians, which is the same as 0 degrees, and a half circle is pi radians. If you did another half circle around in the counterclockwise direction, you would get 2 pi radians, which is the same as 360 degrees or a full circle. If you take the top half of the circle, which represents pi radians, and you divide it in half into 2 equal parts, the top a 90-degree angle is going to be pi over 2. Pi is the same as 2 pi over 2, but it reduces to pi, and then go another pi over 2 around, and we get 3 pi over 2. And then 4 pi over 2 is equal to 2 pi. Now if you take the top half of the unit circle, this top semicircle, and you divide it into 3 equal parts, that would look something like this. And I'm going to divide the whole unit circle into parts that size. And our 60-degree angle is going to be pi over 3, 1/3 of a pi. Add another pi over 3, we get 2 pi over 3 in quadrant 2, and then 3 pi over 3 reduces to pi. Next would be 4 pi over 3 at 240 degrees, 5 pi over 3, and 6 pi over 3 reduces to 2 pi. Next we're going to divide this top semicircle into thirds. So if the top half represents pi, if we put that, oh not thirds, fourths, we'll do fourths. This first part would be pi over 4, and then add another fourth, 2 pi over 4 reduces to pi over 2. Then we would get 3 pi over 4. 4 pi over 4 reduces to pi. And then same thing in the bottom half, keep counting. 5 pi over 4 will be next, then 6 pi over 4, which reduces to 3 pi over 2, and then 7 pi over 4, and 8 pi over 4 reduces to 2 pi. And our last step is dividing the top semicircle into 6 equal parts. And we get, so that's every 30-degree increment would give us 6 equal parts. And we'll do the same on the bottom. Okay, so our first one is pi over 6. Add another pi over 6, we get 2 pi over 6, which reduces to pi over 3. Then 3 pi over 6 reduces to pi over 2. 4 pi over 6 reduces to 2 pi over 3. Then 5 pi over 6. 6 pi over 6 reduces to pi. 7 pi over 6. And then 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 reduces to 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 would be next. And then 12 pi over 6 reduces to 2 pi. And that's your complete unit circle with angles measured in radians and degrees. A couple things to help you remember it, some patterns. If you look at the coordinates of the points, if we take all of our angles that have a 6 in the denominator and look at the coordinates of the points, notice that they're almost exactly the same, root 3 over 2, comma 1/2, with variations in the signs. So in quadrant 1, both x and y are positive. In quadrant 2, you have a negative x coordinate and a positive y. In quadrant 3, both x and y are negative, and in quadrant 4, x is positive and y is negative. But the coordinates of the points really are the same, just with those variations in the signs. All of the pi over 4s are root 2 over 2, comma root 2 over 2, with, again, variations in the signs according to those same properties. And then the pi over 3s, same thing. So if you can memorize those 3 points and remember that all 4 quadrants really are the same points, if you can just figure out the sign of the x coordinate and the sign of the y coordinate, then you're good to go. So I recommend taking a blank unit circle and trying to fill out the whole thing from memory and keep doing it until you're really good at it and you can do it quickly. The next part is evaluating sine and cosine at given angles on the unit circle. Now, cosine is adjacent over hypotenuse, or x over r in the unit circle. So if you take a triangle where theta is the central angle, the x coordinate is the adjacent leg of the triangle, and the y is the opposite. So cosine's adjacent over hypotenuse, r is the hypotenuse. But remember that in the unit circle, r is equal to 1. So that gives just cosine is equal to the x coordinate. And sine of an angle is just going to be the y coordinate because, again, r is equal to 1 in the unit circle. So when you're asked to evaluate cosine of a given angle or sine of a given angle, you're just finding the x or the y coordinate. So for number 3, A, when our angle is pi over 6 and we want to find cosine of pi over 6 and sine of pi over 6, my goal for you is to have the unit circle memorized and to be able to do this without looking at the unit circle. So if you can picture on the unit circle that pi over 6 is that angle that's just 30 degrees above the x-axis, and at that angle you have a long x and a short y. So the x coordinate, which is cosine, is going to be root 3 over 2, the greater number, and then sine, that short y value, is going to be 1/2. In part B, at negative 3 pi over 2, so we want cosine of negative 3 pi over 4 and sine of negative 3 pi over 4. Negative 3 pi over 4, you can see where 3 pi over 4 is on the unit circle that we just filled out. Well, negative 3 pi over 4 is that same distance, but remember that your initial side is on the x-axis and you're swinging down 3/4 of the way, so 3/4 of a pi. So that's going to be in quadrant 3. So that would be 1 pi over 4, negative pi over 4, negative 2 pi over 4, and negative 3 pi over 4. So it's in quadrant 3. Both the x and y coordinates are negative. It's coterminal with 5 pi over 4. And so our answers are going to be, both of them are going to be negative root 2 over 2. And then part C, cosine of 11 pi over 6 and sine of 11 pi over 6. Cosine of 11 pi over 6, the x-coordinate is going to be root 3 over 2. Sine is the y-coordinate, negative 1/2. So again, at 11 pi over 6, which is down here, it's the long x and the short y, as opposed to the pi over 3s where the x is short and the y is long, and the 1/2 and the root 3 over 2 get switched. The last part of this lesson is finding the length of an intercepted arc. Now the book gives this formula S equals R times theta, but I want to show where that comes from. So let's make up an example. Let's say theta was, I'm going to start in degrees, 120 degrees. The length of this arc, which is called S in this case, would be the circumference of the circle times the fraction of the circle that angle represents. So 120 out of a full circle, which is 360, which would be the circumference times 1/3 in this case. But in radians, we're going to do the circumference times the angle theta out of 2 pi instead of 360. Now, circumference is 2 pi r times theta over 2 pi. Well, the 2 cancels, the pi cancels, and we end up with the length of the arc, S, is equal to the radius times the angle theta in radians. So we're going to use that formula to find the length of the arc. So in number 4a, using that formula, well, this time instead of s, we're going to call that a, because that's how it's labeled, the length of that arc. So we're going to do a equals the radius, which is 4, times the angle, 7 pi over 8. I can cancel. 4 and 8 can both be divided by 4, giving me a 1 and a 2. And we get a equals 7 pi over 2. And if you plug that in your calculator to get a decimal approximation, it's about 10 point, I think it was 995, but it says to round to the nearest tenth, so we're going to get 11.0, and this is in inches. Okay, the next one. This one's got a little bit of a twist to it. The arc that we are trying to find, W, is here, but the angle given is the rest of the circle, not the part we actually want. So if a full circle in radians is 2 pi, we need to do 2 pi minus 5 pi over 6 to find the angle that we need. So we need common denominators, so I'm going to multiply 2 pi by 6 over 6, giving me 12 pi over 6 minus 5 pi over 6, and that would be 7 pi over 6. So the angle that we are actually going to use is this angle, 7 pi over 6. So now, using our formula, W equals the radius, 4 centimeters, times 7 pi over 6. The 4 and the 6 can both be divided by 2, giving us 2 and 3. And then multiply the top times the top, we get 14 pi over 3, which is approximately 14.6608, I think. So rounded to the nearest tenth, about 14.7 and centimeters in this case. Okay, and then the last example, we have, this one's not as bad as the last one because the angle given is the one we need. So we're going to do C, which is this intercepted arc, is the radius, 2, times the angle, theta, pi over 3, and we end up with 2 pi over 3, which is about 2.0944 according to my calculator. So rounded to the nearest tenth, about 2.1 feet.